Hi, it's Allison from East Cobb Tutoring Center. I have a log expression here and we are going to expand it, which means we're going to write the word log as many times as possible and go from just one little log to one very large log expression. So the first thing I'm going to do here is use my coefficient and move it to the back as an exponent on both of those variables. So it's going to look like this. The log of xy cubed, or the log of x cubed, y cubed, like that. The last thing I'm going to do here is break this up using my product rule or my sum rule, and it's going to look like this. The log of x cubed plus the log of y cubed. And that's it. Now, a couple of notes about this. First, this could have been any base. It could have been log, base 2 here. If that were the case, then I would have just put a 2 on all of the logs. Or we could have even started with a natural log problem, like the natural log, 3 natural log of xy. And the result would have been the same, except that instead of saying log base 2, it would have said natural log. Let's take a look at another example. All right. So in this problem, the first thing I'm going to do is deal with this division bar here. So basically, anything that is in the denominator of our fraction is going to wind up being subtracted or negative. And like I said before, it could be any base, could be natural log, could be common log, which is what I have here. And now all of the products are going to be added. So it's going to look like this. The log of 4 plus the log of x plus the log of y, log y, and then minus the log of 3, and then minus the log of z. I want you to just look at this last part again. We really had the log of 3 plus the log of z, but because I was subtracting the whole thing, I distributed the negative, and that's why both of these terms became negative. So a good shortcut to think about is anything in the numerator is a plus and anything in the denominator is a minus.